Thank you. So I'm just going to take a brief moment to thank Stephanie and Philip for organising this session, so it's a pleasure to be here. So I'll be talking about our work that investigated function architectures that underlie auditory speech repetition, and the premise or the thing that I'm going to try and convince you is that there's different ways that the effective or the directed connectivity would manifest when we're considering auditory speech repetition, and hopefully I'll provide you with sufficient evidence by the end of the presentation. So, sorry, I'm trying to get it to go to the next slide. Okay, perfect. Okay, so I want to start off with a bit of background. What do I mean by... okay, I'll just... yeah. Okay, thank you. Okay, so what is auditory speech repetition? Well, it's a simple language task that requires both the perception and production of heard words, and it's instantaneous. And I'm showing a little pictorial graphic over here where the subject is being presented with the word triangle, and they're instantly repeating it. So what I'm interested in is understanding what is the functional architecture that underlies this processing. And under the classical neurological model of language, what we can see is that it requires a sequential flow of information, recruiting 4 left hemisphere regions. So the first one under this particular model is the auditory cortex that propagates information to Wernicke's area, which I'm highlighting over here in green, onto Broca's area, which is responsible or involved with motor imagery of speech, and then propagating information onto the primary motor cortex, which is involved in speech articulation. So there's lots of recent empirical studies that have actually questioned the validity of this model and said it's kind of sort of outdated. But when we look at auditory speech repetition, these regions are consistently activated. So then the question becomes, what is the directed influence between the regions during the task at hand? So the question that we are going to be answering during this presentation is looking at understanding the variability in that functional architecture. So is it a linear flow of information that we're seeing in the black arrows over here as posited by the neurological model, or is it 2 alternative routes that we see in red and purple over here? So in order to answer that question, we looked at data from the Plurus database that was collected at the Wellcome Center for Human Neuroimaging. And from this database, we looked at 59 healthy subjects who were native English speakers, and they were neurologically intact. For these subjects, we considered activations when repeating heard words in different fMRI scanning runs. So these activations were collected for the regions of interest, so the M1, POP, PSTS, and A1. For the task at hand, we looked at the peak activations for each subject and constrained it anatomically based on the brain atome atlas. So you'll notice that for all of them, I've got additional sort of hyphenations. That just means we're considering variability in the regionals that we're considering. So once we have the fMRI time series for each of these tasks, we looked at the causal directed influence between the neural populations using Dynamic Causal Modelling, like Philip mentioned, so DCM for fMRI. So basically, it introduces a gentle model where you have a forward model that is taking a neural dynamic and predicting your ball signal, and then it can also be used to invert the ball signal to estimate the neural dynamics at play. So in our work, we were really interested in understanding what were the neural dynamics or the effective or directed connectivity underlying the task at hand. So for this, we introduced an individualized hypothesis, so we estimated a DCM per subject, and we relaxed the assumptions that the neurological model is imposing. So for this, we introduced the input region as the auditory cortex, which is propagating information to all regions except the motor cortex, or M1, because of anatomical constraints. And then we had POP and PSTS as being functionally at the same level as denoted by these bidirectional connections that you see between both of them. And then M1 is the output region of the final, which is propagating information to all the regions of interest. So all of these connections can be estimated as excitatory or inhibitory, and we have backward and forward for them. So once we have these individual estimates, we looked at group level effects, which were estimated using parametric empirical Bayes. So I'm running out of time, so I'm just going to quickly talk through the results and hopefully give you the key takeaway points. So at the group level, what I'm showing you over here are the results for it. So red is the positive connectivity of at 1, and negative is shown in blue at -1, and the gradation sort of shows the in-between. So there are two salient key takeaways that I want you to take away, is the fact that there's this positive connectivity that we get from PSTS to M1, which is not consistent with the neurological model, and also the bidirectional inhibitory connection between PSTS and POP. So what's really nice is that it actually estimates or sort of gives hypothesis of these different functional routes for auditory speech repetition that are not consistently aligned with the neurological model. So we wanted to look at this further, and we validate it across different auditory stimulus, so words and pseudowords, and also different regional configurations. And the next step was to really validate it at an individual level and see what's happening. So we looked at the surprising connectivity between PSTS and M1 across subjects. So we want to categorize and really understand at a subject level what's happening. So what I'm showing over here is a group level sort of separation based on the strength of the estimated effective connectivity that we're seeing on the x-axis for PSTS to the motor cortex, and on the y-axis from POP to M1. And the key thing to note is that the positive, or the big cluster over here, is the one where we have positive connectivity from both areas. So when we look at this, we see a really high variable result across the different regional configurations. And we can even sort of look at it further, and we see that majority of the models have this positive connection, especially when we look at it by individual. So we're seeing that on the y-axis. And this is also consistent across the two stimulus that we're looking at for speech repetition that we can see over here. And I think for me, what is even more important is that only 2%, so 10 of the models that we had, were actually consistent with the standard approach of thinking about I guess, the classical neurological model here. So just following on from that, we looked at within subject variability. So this is going from across to within, so we want to know if we change or perturb the regional configurations, how consistent is this functional architecture. So if it's really consistent, you'll see that on the sort of the zero axis with low degeneracy or single group membership, and if it's not consistent, we'll see it at the other end with all group membership. And what we observe is that 73% of our subjects were assigned to greater than 2 groups, which means that there is a lot of variability even within subjects when you perturb that regional configuration. So what does that take us? Well, at a group level, it means that there is different functional routes for auditory speech repetition that aren't consistent with the neurological model, and also sort of give us mechanistic understanding of why, when there are critical lesions in Broca's area. So we had a paper in 2021 that highlighted that you could perturb Broca's area and speech impairment didn't really take place. So that this is one of the accounts where potentially there's this other route that you were able to shift from one regime to another in order to do your functional processing. But I guess when you look at group level, you sort of forget about the intra or the inter-subject variability. So when you're thinking about how regime shifts might happen, I guess one of the key takeaways I want you to have is that always think about an individual and take the group level as a sort of a starting point. And on that note, I just want to thank all my collaborators and my PhD supervisor, Carl, and Kathy, whose data I was presenting today. So thank you. And also the QR code for the paper in case anyone's interested.
Thank you very much. In the interest of time, I'm sorry we have to cut the questions, but just find us after the session and we're happy to answer more questions directly. Thank you.